Now let's take a look at where we're gonna use trigonometry substitution. Whenever you have an expression like a number, any number square, and then minus some variable square, or some variable square minus any number square, or the other case is the plus case. So you have a variable square plus the number square. Then we're gonna know that we're gonna use trigonometry substitution. So it doesn't necessary to be a square root or anything. So as long as you see these expression. So for example, like you see, oh, x squared plus 16, and it's in the denominator, then we can use trigonometry substitution. Of course, if you see x squared plus 16 data on the numerator like this, then we're not going to think about this case anymore because this is easy to take the integral. However, when there's a fraction like this, then the basic integral doesn't work or u sub doesn't work, then we may think of the trigonometry substitution, okay? And there are three different cases that we can use our trick to sub. The first case is when you have a number minus a variable. Then we let A is sign. And then if the variable minus a number, then we're gonna use the secant. And then if it's a plus, then we're gonna use tangent. So let's apply that to this problem. So I have dx over 25 minus 8x squared, and the whole thing to the power 3 over 2. So I do see some number square. So 25 is a perfect square of 5. So 5 squared. So a number square minus some variable square. So number minus variable. I know that I'm going to last that variable, whatever the variable under the square, equal to a sine theta. So now we're going to figure out what is our A. Our A will be the number, right? The n square of that number. So it's going to be A going to be 5 because A squared is 25. So my A will be 5. And then where's my U? My U going to be AX. So this is my U. Okay, so I'm going to let U equal A sine theta. And my U is 8x. So I will have AX equal 5 sine theta. Okay, so this is the trigonometry substitution. After you let your, you have the tricks up, you need to take the derivative all the time, right? So I'm gonna divide both sides by 8. So I will have x equal 5 over 8 sine theta. And now I'm gonna take the derivative both sides. The left-hand side is dx, and the right-hand side is 5 over 8 cosine theta d theta. So this is my u part, okay, u part, and then now I'm gonna sub back into my original integral. So my integral now will become the dx. The dx now will become this stuff right here, right? So I'm gonna have 5 over 8. So since 5 over 8 is a constant, I'm gonna bring it to the front, and I'm gonna have cosine theta d theta to replace my dx, and then all over 25 minus 8x, and my 8x gonna be my and 8x gonna be the 5 sine theta because my 8x is right here. Okay, this is my ax. My 8x equal 5 sine theta. So gonna be 5 sine theta and the whole thing squared. Then to the power 3 over 2. Okay, so since this is 5 sine theta squared, so I'm gonna square the 5 and then square the sine theta as well. So this gonna be 5 end up turning to 25 sine square theta, and the whole thing to the power 3 over 2. So now we're gonna take care, and what is the purpose of trig sub? Is we're gonna turn anything that is two term, a minus u squared, into just one term square. That is the purpose of trig sub. And that will work for this case because if you take a look at 25 minus, I'm going to do a sine, 25 minus 25 sine square theta. This isn't that just 25. If I factor out 25, I'm going to have this is 1 minus sine square theta. And we're going to have the trigonometry identity is 1 minus sine square theta is cosine square theta. So this is going to be 25 cosine square theta. That is the purpose of trigonometry. So we turn two terms using trig identity and make it become only one term. So we will have 5 over 8 and then cosine theta, d theta, all over 25 cosine squared theta and the whole thing to the power 3/2. Now we make our expression become something all in trigonometry, and we want to simplify to see anything possible. So it looks like in the denominator, since this is on only one term and raised to the power 3/2, we can use the property of exponent. If you have anything that the product of two quantity raised to the same power, we can do a to the power m and b to the power m. So it means I can distribute the power 3/2 to both of them. So I will have 25 to the power 3/2 times cosine theta 2 times 3/2. Okay, because b to the power n raised to the power m is gonna be b n times m. Okay, so they're gonna multiply the power, and then 25 to the power 3/2. If you could do that by mentally, that's fine. Otherwise, you're gonna use calculator, and we're gonna have 25 to the power 3/2 is 125. So I will have 125 here, and 2 times 3/2 is gonna be 3. So I'm gonna cosine 3 theta. So this gives us 5/8 integral of cosine theta over 125 cosine 3 theta, d theta. And looks like we can still simplify more by cancel out one of the cosine on the numerator and denominator. Also, we can multiply the number together. So I'm gonna take 5/8. I take 8 times 128, or 5 and 128. 5 can be divided. Okay, so this is 1. This is 25. So I'm going to take 8 times 25 is 200. So we're going to end up having 1/200 to the front. And then the inside will be 1 over cosine square theta, d theta. Because cosine and cosine in the denominator cancel out one copy. So I will have 2 copy left. And if you remember trig identity, we will have 1/200 integral of secant squared theta d theta. And what is the integral of secant squared theta d theta? We know the derivative of tangent is secant squared. Derivative of tangent theta is secant squared theta. So it means the integral of secant square theta is tangent theta. So we end up having this to be 1/200 tangent theta plus c. Okay, so from the very long substitution, we thought we are done with the final result, but it's no. We have to now turn this back. With the next step is we need to turn this back to expression of x. Okay, and how do we gonna do that? We're gonna use the place where we get out less our x to be something. So on the above, I have x equal 5/8 sine theta. So from here, I'm gonna get back my tangent. So x equal 5/8 sine theta. Oh, I should get from here. I should not get from here. I should get from this line. So 8x equal 5 sine theta. And I'm going to isolate for theta as for sine. Then I'm going to have 8x over 5 is sine theta. So in trigonometry, if we put that in the right triangle, right triangle where theta is. We know sine is opposite over hypotenuse. So 8x is my opposite of the theta. So this is going to be 8x. And then hypotenuse is 5. So hypotenuse right here. So it's 5. So 8x is the opposite and 5 the hypotenuse. Now we're going to have to look for adjacent. And the trick part is all the time any missing side length will involve the expression that you have above 25 minus 8x squared. So that is true because the adjacent will be square root of 25 minus 8x squared. Okay, so that is going to be my expression. So now, so using the help of the triangle, we can find tangent theta is equal opposites over adjacent, which is ax, over the expression that we just found, so 64x squared. Now that back to our final answer, we have 1 over 208x over square root of 25 minus 64x squared plus c. That is our final answer for the integral of this